Good morning, this is your Math Sensei, Mr. Spensei, and today we're going to work on finding slope of a line, particularly from a graph. First off, slope is often referred to as rise over run, and what that means is the rise, which is the change in y over the changes in x, or some people like to say the difference in y over the difference in the x values. All right. And that's all that triangle means is difference. Difference in y, difference in x, or change in y, change in x. It actually has this formula here. M stands for slope. And if you had an ordered pair, x1, y1, and x2, y2, that would be the formula you would use to find slope. We're not going to use that formula today. We will tomorrow, but today we're just going to work on calculating slope from a graph. First off, slope is a ratio comparing the amount of change or difference in the y values, which is what we wrote, to the amount of change, the difference in the x values of two ordered pairs. And that's what we just said here. So finding the slope from a graph, mark 2 points anywhere on the graph. Well, we actually have 2 points marked right there. And find the change in y is a positive direction. And by the way, y goes in the numerator. So if I have to go, I'm starting here and I'm going up. So that's positive. So I'm going up 1, 2, 3, 4, 5, 6. I went up 6. And counting over in the x direction, it's also in a positive direction because I'm going right 1, 2, 3, 4, 5, 6, 7, 8, 9. So we get 6/9. Now using Desmos or your calculator, you can reduce that and we get 2/3. And we always want to reduce. So in this case, M equals 2/3. So that's the slope on that one. Had I chosen another 2 points, I could have chosen these two because those are where I have pretty points where it crosses perfectly. And in the y direction, I notice I go up 1, 2. In the x direction, I go 1, 2, 3. So I end up getting 2/3 that way as well. So doesn't matter what 2 points you choose as long as it's where they cross perfectly or they're called pretty points. Okay? Got to tell you something. Positive slopes are going up and to the right. I can look at this without even counting points. I know this is positive because it's going up and to the right. Whereas down here, I know I'm going to have a negative slope because I'm going down and to the left. Down and to the left is always negative. Up and to the right is always positive. So it says, okay, find the slope of A over B. So if I'm doing A over B, I'm going 1, 2, 3, 4, 5, 6, 7. Oops, excuse me, I miscounted. Do that again. 1, 2, 3, 4, 5, 6. 6, and then 1, 2, 3, 4. 6 over 4, that reduces to 3/2. On the other hand, if I'd done C to A, and this should have said, instead of A over B, it should have said A to B, and C to A. If I was going to C to A, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I went up 12 in the Y direction. And I went over 1, 2, 3, 4, 5, 6, 7, 8. Well, I can divide both of those by 4, so they reduce, and I can use Desmos to do that. So either way, when I get that, I get a slope of 3/2. So it doesn't, like what I wanted to prove to you or show to you, is it doesn't matter which 2 points I choose, as long as I reduce, I'll get the same response. And we can use Desmos or your calculator to do the reducing. Okay. Slope-intercept form. Kind of been already introduced to that. You saw it in middle school, and it has the form y equals mx plus b. Y is the y coordinate, x is the x coordinate. And what that means is if you have an xy point, this is that same x and this is that same y. This is our slope that we just talked about counting out, and our y-intercept is where it crosses the y-axis. And here's what we know. This is going to be some zero, and then it's going to be a y value. The x will always be zero, and then wherever it crosses the y-axis. So this makes a linear equation. It's a straight line, and we're going to go ahead and write these out. So it says first, for rewrite the slope as a fraction in the form y over mx. So if I do that, my fraction is going to look like this. It's going to be m equals 2 over 1. It also doesn't say do this, but we're going to do this. B equals -4. So my y-intercept has the form 0, -4. This one, my slope is going to be m equals -3 over 1. So b equals 2. And my ordered pair for my y-intercept is 0, 2, where this is my x and this is my y. Here it's already a fraction. So m equals -1/2. And it could be or 1 over -2. It doesn't matter where you put the negative as long as you only have one negative. In this case, b equals -5. So our ordered pair is 0, -5. This one's weird or a little bit interesting. We're missing a number in front. The number we're missing in front is 1. So m equals 1 over 1. And in this case, b equals 8. So our ordered pair is 0, 8. And the last one, we say, well, there's missing that 1 again. So m equals 1 over 1. I don't have a b because essentially I'm adding 0. So b equals 0. So this goes through the ordered pair, and this is 0, 0, because our x is always 0 for our y-intercept. And then a y is whatever the y value is. That should be a y, not an x. Okay. For the graph, record the rise and run. Well, when I count this out, I have 1, 2, 3, 4, 5, 6. Okay, but I went down 6. And then I went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. Yes. So my run was 10. So this reduces out to, so my rise was -6, my run is -10, so -6 over 10. This reduces, and you can use the calculator to do so, or the Desmos, and we get -3/5. Now, someone's going, what if I'd gone the other way? Well, let's try the other way. Well, going up is positive. 1, 2, 3, 4, 5, 6. So that's a +6 up. But if I go to the left, it's negative. So I get -10 because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I do get a -10. And this reduces to -3 over 5 as well. So it doesn't matter which way you go, just know that going to the right is positive, going to the left is negative, going up is positive, and going down is negative. So either way, the slope of that graph is -3/5. All right, appreciate you watching. Look forward to seeing you on the next one. Thank you.